All right, good morning. Welcome back to Precalculus. We're going to be doing this problem number six, no, problem number nine. Okay. This is a system of equations, three unknowns, three equations. This thing says use t as the parameter for your free variable, giving us a hint that there's probably a dependent system going on here. But let's go ahead and find out. So the way I like to do these is I like to go slow because I've gotten the wrong answer before and it just takes longer and I go slow. It's like a slow and steady wins the race better than trying to be clever about it. So what I'm going to do is I'm just going to multiply row three by negative one. Okay, and I'm just going to write down row one and row three because I'm looking at row three because it's the easiest match for row one. So we'll do that one first. So we'll say, okay, here's row one, 3x1 minus 2x2 plus x3 equals 4. And I'm just multiplying row 3 by negative 1. So we have negative 3x1 minus x2 minus 4x3 equals negative 25. We're just going to add these guys together. The whole point is I kind of want to get rid of what I want to do. I want to kind of get rid of my x1s first, right? If I could knock those guys out, then the rest of the problem gets to be a little bit easier. It doesn't matter if you pick X1, X2, or X3, but pick one and go with it to eliminate those. Like X3 wouldn't be a bad choice in this problem because there's only one X3 in the top row. So we can go ahead and figure out like how to eliminate the other two. Okay. But anyway, we can do this. Pick a variable and choose to eliminate that in all of the rows below the first one. Right? And let's just add this up. We have no more X1s when I add these two equations together. We have minus 2 minus 1. We have minus 3x2. And then 1 minus 4. That's going to be another minus 3x3. And then we have 25 minus 4. I believe that's going to be negative 21. All right. At this point, you can leave it as is. You can divide it. I notice that everybody's divisible by 3 here. Let's go ahead and do that before we go any further. It's just to keep the numbers smaller. So I have negative x2 minus x3. Actually, I'm going to multiply by negative x3. Okay. And the reason why is I also notice that all of these are negative numbers. And negative numbers they have their uses. Okay. But for keeping things as small as possible, let's go ahead and say that's equal to 7. Right. And that's what I did with the first one here. All right. And that's my new and improved row 3. This is my new row 3. But we'll just hold that off to the side there. Okay. The next thing I'm going to do is now we have to accomplish the same thing for row 2. I want to get rid of this x1 in row 2. So what I'm going to do is I'm going to multiply row 2 by negative 3 because when I add these together, the x1 term is going to go away. So let's go ahead. I'm just going to rewrite my first row. Okay. And you probably don't have to do this. Um, as a condition of the fact that I will never quite look at this the same way again. Um, you probably don't have to do all of these steps to do this. I still feel more confident doing all of the steps to make sure that I'm not going to mess up. But you'll probably skip this one and just multiply row 2 by negative 3. Okay, but like I said, I like to line them up so that I don't lose a piece. Okay, and we're just going to say this is going to be negative 3x1. We're multiplying everything here by negative 3. Don't forget the right side. Okay, 3 times 2, we have negative 6x2. Okay, and we have negative 9x3. And then we have equals negative 60. Don't forget the right side. Okay, and now what I'm going to do is I'm going to add these two pieces together. I'm looking at this and hoping that I'm going to be able to divide by something later. Okay, so the x1s, those go away, they cancel out. Okay, we have negative 6 minus 2, so we end up with a negative 8x2. Okay, negative 9 plus 1, we still have a negative 8x3. Okay, and it is equal to, and this looks like negative 56. Okay, so let's go ahead and see if we can't divide. So I'm looking at this, I'm saying, why don't we divide everybody by 1/8 or negative 1/8? Okay, so this is my new row 2 when I'm done with it. So we have x2, negative 8 over negative 8, negative 8 over plus x3. and then equals, and it looks like we're going to have a 7. 56 divided by 8 is going to give us 7. Okay, this is my new row 2. And then what do you know? I'm looking at row 3, x1 plus x2 is equal to x1, x2 plus x3 is equal to 7. Row 3, x2 plus x3 is equal to 7. We could regroup this stuff, but I don't think we really need that step. But I would say, okay, 3x1s. Okay, let's just go ahead and do it that way. So we have 3x1s minus 2x2s. So I'm going to go down here. If we have 3x1 minus 2x2s, okay, just looking at my first row here, plus x3 equals 4, plus x3 equals 4. My new and improved second row is going to be x2 plus x3 is equal to 7. x2 plus x3 equals 7. My new and improved row 3 is x2 plus x3 equals 7. Okay, I'm not going to do an extra step in there. So at that point, just to kind of regroup and see what we've got, we can say, wait a minute, row 2 and row 3 are the same thing. When I take row 2 minus row 3, this will be the only time I actually use subtraction, they're all going to cancel. So this is going to look like my system of equations is now going to look like we have, let's see if I can't. So I have 3x1 minus 2x2 plus x3 equals 4. I've got x2 plus x3 equals 7. And then when I go ahead and subtract them, we have 0 plus 0 is equal to 0. This is telling us, hey, you have a free variable. Generally, the row that you have for your free variable is the free variable you're going to pick. Like the pivot for row 3 would be x3. So we're going to say set x3 equal to my t. If I had done this for row 1, I would say let x1 equal t. If I'd done it for x2, let x2 equal t. All right. So that's how I pretty much try to set this thing up. All right. Once we have that, we can go ahead and say, well, x3 is going to be t. Let's go ahead and take my row 2. We have x2 plus x3, which is now t, is equal to 7. So t is equal to, I'm sorry, x2 rather, is equal to 7 minus t. All right, and that's where we are with this. Now, what I'm going to do now is I'm going to take both my x3 equals t and my x2 equals 7 minus t, and I'm going to plug them into uh, all the variables for row 1 so I can solve for x1. So we have 3x1 minus 2x2. x2 is going to be 7 minus t, and then x3 is just going to be t, and this is all equal to 4. Let's go ahead and sort this out. So we're going to say this is 3x1. Okay, okay, so we have 3x1 minus, be careful with your distributing here. So we have minus 2 times 7, plus 2t, because minus times a minus is a plus t is equal to 4. All right, and at that point, let's go ahead and we're going to combine like terms and get things to the other side. So we're going to say this is going to add 14 to both sides. Okay, and we're going to say this is 3x1 plus 2t plus 1t is 3t is equal to 14 plus 4 is going to give me 18. All right. At this point, I'm looking at this and saying we can divide everybody by 3. Okay, it doesn't really matter how we do this. We'll say 3x1 is equal to 18 minus 3t. So x1 must be 1/3 times 18 minus 3t. And then we're going to go ahead and distribute this. We're going to say this is equal to 6 minus t. That's equal to my x1. So my solution set for this system is looking something like 6 minus t, comma. What was my x2? I have to go back and look this up. It's 7 minus t. Okay. And then finally t. And that's my solution set. P can be any value you'd like. Okay, technically, let me write this more properly. Okay, it's t such that we have 6 minus t, 7 minus t. Actually, let me do a little bit more formal. Okay, we'll go ahead and write it this way. We'll say t is an element of the real numbers, 6 minus t, 7 minus t, and t. Okay, regardless of what I pick for t, right, we could generate an infinite number of solutions, but they all have to look like this. So if I pick t is equal to 0, then 6, 7, 0 would be an answer. Okay. And if I pick t is equal to 1, we'd have 5, 6, 1. T is equal to -1. We'd have 7, 8, -1. So whatever you pick for t is going to be fine. You can test that out and plug those in. So if I set t equal to 0, okay, we're going to get the answer of 6, 7, 0. Okay, and we could go ahead and plug that into the initial original equations and see if it actually works and if I get true answers for all of what's going on here. Okay, and that's pretty much what you would do with all of this. Okay, so that's how you solve one of these problems. Just take it slow. Try to line up all the variables so that you're making sure that you're adding up the right ones. Take your time with the arithmetic, making sure all of that works. There's a lot of places that you can mess up. So there's a lot of room for like we can make a lot of mistakes. So just slow so that we don't have to do it again. Just slow so you don't do something like, add 1 and 1 to get 11 or something ridiculous like that. Okay. So just try to take your time with it. As you do these problems, you will find things that you will have to do that I don't have to do. You will find things that you do have to do or that I do that you don't have to do. Okay. So you'll say, oh, I can go much faster than that. Like, yes, I'm sure you can. A lot of people can. I've never been very good at these things. And I've always found it a better strategy for me just to kind of go slow so that I don't have to repeat a problem and I know I'm going to get the right answer. Okay. Thank you very much for watching the video. Good luck studying, and I'll see you in the next video. Thank you.